Back at it with video problem number 2. So for this weekly homeworks video problem, we are given a system of equations. We are asked to solve the system, write the solution in parametric vector form, describe geometrically what the solutions look like, and then we are asked to analyze the homogeneous system, which just states that the right-hand side of all these equations is equal to 0. So, and discuss how the solution set changes between the inhomogeneous and homogeneous. So let's get right into it. This is our given system of equations, and we can easily convert that into an augmented matrices, and then just through simple row reduction, we come to find that x3 is a free variable, and with our row reduced echelon form, I rewrote our system of equations and let x3 be the variable t, and then that follows that this is our parametric vector form. And looking at the homogeneous, again, it's the same augmented matrix except that the augmented bit is all zeros. So again, simple row reduction, and we are left with this as our solution set. So if we write them side by side, we see they are drastically similar. The only difference would be the initial conditions. So when t is 0, the homogeneous solution is 0. X and y are 0 respectively, and when t is 0 for the inhomogeneous, we have both x and y coordinates. So if we hop over to GeoGebra, we see that if we graph the inhomogeneous solutions, these are the planes that we see, and we know that the line that is generated by the intersection of these planes is the line that all of our solutions to the system exist on. We can show this. So if we graph the plane x equals -5 and y equal to 3, we see that the intersection of those planes lies exactly on this line. And again, we see that occurs at z equals 0, which satisfies the initial conditions that occurs z equals 0. So another example, if x is -9 and y is 6. Now, if we graph x equals -4z, which is the same x minus the initial condition that when z is 0, x is -5, and y equals 3z, so just neglecting the initial conditions here, we expect our solution set to go through the origin, since all variables will be 0 if z or t, same thing, is 0. So we see the line that all of our solutions exist on is parallel and just shifted slightly down from the line we get when we have no initial conditions. So geometrically, the solution set to both systems of equations is a line, and just based on the initial conditions when our free variable is 0, we will have a different parallel line. Thanks.